Unit 1A, Lesson 7. This lesson aligns with 11.2 and 11.3 in your textbooks. The one standard we are going to cover in this lesson: derive the formula for the sum of a finite geometric series when the common ratio is not 1, and use the formula to solve problems. Before we discuss what a series is, we first need to know what a sequence is, and there are 4 different sequences. First, we have a finite arithmetic sequence, which means we have a list of numbers, and each time the list is going to increase by the same value. So if I start with 1, I'm going to add 2 to get 3, add 2 to get 5, add 2 to get 7, and then add 2 to get 9. This is finite because we have a set number of terms. This pattern does not continue on. Once we get to 9, it's done. So an infinite arithmetic sequence is going to be the same thing. We're adding a value every time, except this pattern is going to continue on. So I start with 2, I add 5 to get 7, add 5 to get 12, add 5 to get 17, and this pattern would continue on and on and on. We can also have geometric sequences. So a finite geometric sequence, we're multiplying by the same value each time. So if we start with 2, I multiply by 3 to get 6, multiply by 3 to get 18, multiply by 3 to get 54. This is finite because it comes to an end after 54. The pattern does not continue on. Infinite geometric, if I start with 5, multiply by 2 to get 10, multiply by 2 to get 20, multiply by 2 to get 40, and these ellipses, 3 dots, say this pattern is going to continue on. That's how we know this is an infinite geometric sequence. All right, so all 4 of these different types of sequences, that's going to lead us now into a series. What is a series then? A series is simply the sum of the terms of a sequence. We talked about the 4 different ones previously. If we take all those terms of that sequence and we add them all up together, that sum consists of the series. So looking on this page, we have a chart that organizes sequences, finite series, infinite series for arithmetic and geometric. In the upper left, we have a sub n, which stands for the nth term in the sequence, depending on how long that sequence goes, or that series. A sub 1 stands for the first term, D is the common difference, and R is the common ratio. So if we look at the arithmetic sequence, what this is saying, if we look at any term in that sequence, the nth term is going to be equal to the first term plus the number of our nth term minus 1 times the common difference. Okay, the common difference, we're adding that same value each time. Then you can look and see we have formulas, 2 different ones for an arithmetic finite series. There's actually no formula for an infinite series. It's not applicable. And geometric, we have one for a sequence, and we have a formula for the finite series for geometric and for an infinite geometric series. Okay. You should record all these in your notes. We're going to discuss them more in class. The one we are going to focus on in this lesson the most is the finite series for geometric. All right, so make sure you have this formula down. We're going to go through where this formula comes from next. A lot of this notation is going to be confusing. Obviously, there's not very many numbers involved, so that tends to be more confusing anyways. What you need to do is just record these steps in the process, showing us how we start with our basic form for a finite geometric series. Take these steps to come up with that formula that is a lot easier to work with. All right. What this stands for, this is this S sub n. This stands for summation. So a finite geometric series, it's a summation. A stands for the first term in the sequence. R is our common ratio. So if we go from the first term, we're going to multiply it by the common ratio to get the second term. To get the third term, we're taking our first term, multiplying it by the common ratio not once, but twice, which is where the r squared comes from. Okay, so write this down in your notes. Try to understand the steps going down, but we will discuss this more in class, showing where this formula comes from. A stands for the first term, R is the common ratio, N is the number of terms in that particular series. To end this lesson, we're going to go through a few examples of finding the sum of a finite geometric series. These series are going to be in summation notation. So in this notation, we're going to have to identify some of the key parts in order to use our formula. All right. So in this first one, first thing we need to find is how many terms are going to be in the sequence. N equals 0. That means we're starting at an n value of 0, pretty self-explanatory. The 8, this is our upper limit. So we're going from 0 to 8, which is actually 9 terms. So in this series, we have 9 terms. This is going to be equal to a sub 1, which stands for our first term, which is what the 3 stands for. We're starting with 3, multiplying it by the common ratio. All right, so we have 3 multiplied by 1 minus the common ratio, in this case, is 2. 1 minus 2 raised to the 9th power. And that is all divided by 1 minus r, so 1 minus 2. When we're filling this in, once you're probably going to use a calculator at this point, make sure you're using parentheses around this whole numerator and parentheses around the denominator if you don't simplify it right away. Otherwise, you're going to come up with a wrong answer. So if you type this in on your calculators, you should get 1,533 for the sum of this finite geometric series. One more example, we want to find the sum of this finite geometric series. We have n equals 1 to 20. Remember that this first number, that is going to be our initial value, a sub 1. 4/3 is going to be our common ratio. All right, so now we want to fill in what we know about the information needed for this formula. S sub n, how many terms do we have in this series? We're starting with 1 and ending with 20, so this is actually going to be S sub 20 in this time. It's a lot easier when we're not starting n at 0. This is equal to a sub 1 is 2 times the quantity 1 minus 4/3 raised to the 20th power. And that is all divided by 1 minus r, which is 4/3. Again, you're going to want to type this in on your calculator. Make sure you're using parentheses when necessary. And if you type this in, you will get approximately 1,886.02. So identify what your initial term is, what the common ratio is, how many terms there are, and then use the formula we're given to find the sum of a finite geometric series. In this lesson, we went through what a sequence and series are. We talked about the 4 different types of sequences: finite arithmetic, infinite arithmetic, finite geometric, and infinite geometric. We looked at all the formulas for all of those sequences and series. We also looked at how to derive the formula for a finite geometric series. We'll go through that more in class. Just make sure you take a look at that and try to understand the steps yourself. And then we solved a couple problems looking at summation notation of finite geometric series. Okay, we're going to look at a lot more of this in class. It's a lot of new notation that tends to be confusing, so don't get too worked up about it.